Welcome to the lecture and discussion about designing research. This is based on chapter 5 in your textbook, and it's broken up into 3 parts. So this is part 1. Over this textbook and in this section, there are 3 objectives that I want you to consider. You need to clearly understand these. First of all, you need to be able to determine in research, and we're going to focus on quantitative research, whether it's credible or not. And to do this, we're going to look at objectives number 2 and 3. You need to understand the different types of validity and the threats to that validity. And then you need to recognize some ethical challenges that could come up in educational research. So those are the 3 objectives that I want you to concentrate on as we go through chapter 5. Let's start by talking about research design. Remember in the anatomy of an article section and in that lecture, I talked about there being a section on procedures in most of these research articles. And that's where you would find this information and be able to analyze it and look at the validity of the study and the procedures that were used. In educational research, we can follow the same Sullivan's axiom from designing buildings, that the form has to follow the function. We design a research study based on what we want to accomplish and what we want to find out, not because we have a body of data or a convenient sample or anything like that. There has to be a reason for doing it that's paramount. When we plan and organize the design, you're going to learn later on a little bit more about sampling, but the importance of random selection, if possible, just has to be paramount, because that allows you for the right amount of variability and statistically allows you to do a lot more. The context is going to lead to being able to use the results and apply them somewhere else. So a research study in an exclusive private girls' school, you can't generalize that study to the general population across the United States of both boys and girls. And then data collection becomes important. You need to know which instruments to use and how accurately they're going to record what you need to. Now, as you go through design, keep in mind that we have experimental research where you control everything except for the independent variable, and you allow that to vary so that you can see what happens with the dependent variable. That's actually very, very rare in educational research because we simply can't control for everything. Quasi-experimental kind of is a hybrid of that, where we, for example, may take a group of students because they're there and we can work on them together, and we can control some but not all. And then there's non-experimental research, and those will be studies like relationship studies or regression studies where you're predicting behaviors based on past trends. So why does design even matter? Well, design is what everything hinges on. Your conclusions, your suggestions for policy, alternative explanations you could come up with from the data. It all depends on the design that you use as you set up your data. So when you do a research project like this, you're looking for a snapshot of real life. And if there are basic design flaws, you're wasting time, money, energy. But with a good design, you can be really confident that you've got some good answers. So your design makes a difference in whether you can apply it to other settings, whether you can say it's real or not, or it's a good piece of reality, whether you can trust what you find out, and then, of course, whether you can even make sense of it or not. In most research designs, we're trying to find relationships, the bottom line. We're trying to see what happens when you change something, or we're trying to see if 2 things change together. So you have to consider sensitivity first of all. And sensitivity can be a difficult concept to understand, but really all it is the ability to detect something. There are instruments out there that can detect the effects of different, like motivation or a student's ability, and some are better than others at detecting the nuances of each of those constructs. I kind of think of it when a kid has a fever. And mom reaches out and touches the forehead and says, "Oh, you feel hot. I think you've got a fever." That's not as sensitive as if you actually took a thermometer and shove it in the kid's mouth and see if they are actually running a fever. So that the thermometer is a lot more sensitive instrument than the palm of mom's hand. So to do this, we have to operationalize some variables. We have to define exactly what we're measuring so that we even know how to measure it. And when you think of some of the variables we could look at in educational research, this can get really tricky. We look at ability and motivation and happiness and success and status and peer pressure, all kinds of things that influence how people learn and grow. So it can get really tricky to operationalize those in ways that we can find tools that are sensitive enough to measure them. The other important thing to keep in mind with design is that we need some variability. If everyone on the instrument ends up measuring exactly the same way, that's not a good instrument. It's obviously not sensitive enough for what you want to measure with it. If the test measures only students, if everybody scores between 80% and 100%, that's not going to give you as much confidence in your results about an intervention as it would as if the test measured from, say, 60% to 100%. So a good research design uses tools that actually give you a range of variability in your results. Now, there are different sources of this variability, and some are good and some kinds of variability are bad. Systematic variability is what we are trying to get in what I just described. It's related to the variables that are being studied. For example, if you're doing a study with manipulatives in math and the math scores go up, that means there was systematic variability. The math scores you were able to show a relationship. And another one, as TV time decreases, homework goes up. Those are the kind of systematic variability that you want to see. As the age of driver goes up, the number of vehicle accidents goes down. And then when drivers hit a certain age, the trend reverses. Those are systematic variabilities that you want to see in your data if you possibly can. Then where we want to minimize the variability is in the error term. Error is what we label all of the unknowns. And we try to address this with random sampling as much as we can because all of these error pieces can interfere with the measurement that we're trying to measure. If the subjects don't know how to take your test, if the air conditioning goes out that day, if kids are hungry, all of these introduce error variability into your study. And it's so important that in most statistical modeling, we actually record how much of the variability we see because of error. And it's important to include the error term and let your audience know how much fluctuation is there because of all these errors that sometimes we can't even identify them. And then there's extraneous variability. And this is what you try to control as much as you can. And it's really important when you do a research design or you read a research design that you look and see that these are acknowledged and considered. Extraneous variables would be things like socioeconomic status, student ability, gender. We can't homogenize them, so we can control them statistically, and there are ways that we can acknowledge them and factor them out so that more of our variability is based on systematic variability and then the small bit on error, and we can control for the middle section. So there's a real big difference between the error term and the extraneous variability. We know the relationships among extraneous variability and the dependent variable. We know that for example, there's a relationship between socioeconomic status and reading levels or the way that we measure reading progress in schools. But with the error term, we don't know or we don't have a way to measure or capture all of the relationships that are lumped into that error term within the study. So in a good study design, you want to minimize your error term as much as you can. You want to control for the extraneous variables that are introduced into it, and then you want to increase or maximize the systematic variability because that's what your study is truly about. We're going to talk about validity. Validity is a construct that means that what you're doing actually reflects the reality that's out there. It's an accurate picture or snapshot that corresponds to the real world. It's a way of letting the world know that your study is accurate and trustworthy. Validity actually comes from the same word as valor. It's a Latin word that means strong. So it gives us confidence in the study. There are two basic types of internal validity, or of validity in general. There's internal validity and external validity. And your textbook went into some others, but for the purposes of this course, if you can get a clear understanding in your head of the difference between internal validity and external validity, you'll be fine. So internal validity, think accurate with reality. What we're doing internally in this study actually mirrors what happens in real life, and it shows the relationships between the variables. It's not always cut and dried. So you have an IV, and that leads to the dependent variable, but sometimes it's hard to know which one comes first, and it's not always necessarily causal. For example, does the time that gets spent on personal reading influence the reading skills of the child, or do the reading skills of the child influence how much time they're willing to spend on personal reading? So it's not always cut and dried, the relationship that's there in reality. The quality of the teacher, for example, leads to learning games. We're always trying to show the relationships between the variables. External validity, think of what happens when you take it outside of the study. In other words, can you apply it to what you find out to another situation? And this is very often the reason for doing extensive research. We want to answer a question for the world or find a solution that can be used. And you have to design the study so that the results and conclusions are strong enough that they can be applied to other groups. And you have to question it in the study when you're reading it. If we find really strong results for third graders, can we apply that to fourth graders? And this was one of the problems with the old state-created or purchased criterion reference tests. It became very difficult to compare or generalize one state's results to another state's because we were all using different tools. So validity is actually a statistical conclusion. We want to know, are we using the right instruments, and are we interpreting it the correct way? And then are we measuring what we say we are truly measuring? And when you start to think of all of the different constructs that we can measure in educational research, it can be really overwhelming. So it's best if the articles you're reading, if they're using tools and instruments that have already been validated by using them in either through some statistical analysis, or they've been used over and over again. That's going to be preferable to something that the researcher creates themselves and hasn't actually been validated yet. To assess the validity of a study, you need to look first of all at the participant selection. For example, going back to our question of selection or volunteers, or you have to do it, the good old EPY 702 mandate to participate. You have to know in the study how the participants were chosen. Then you have to look at the instruments for measuring the different constructs, how the data was actually collected, and then if there was even fidelity to that instrument, or how the intervention was administered. And really, really important, every time you read a research study, ask yourself, is there anything that was done that could actually lead to an alternative explanation from the one that the author has given? If you can, this is important as we do research. It's not just a textbook example. If you conclude, for example, that manipulatives didn't make a difference in a math classroom because the test you used was so poor it couldn't capture math progress or math knowledge, we've missed an opportunity possibly to help kids learn. But the opposite is also true. If your test is so poor, or the way you gather data shows that manipulatives are the best thing ever, and they really aren't, then we're going to waste time and dollars and energy using something that really that has marginal benefits for students. This is the end of the part 1. So when you're ready, you can move on to part 2.